Now let us see what is Biot-Savart's law. Let this is current carrying wire, and we know that in earlier lecture, current carrying wire always creates magnetic field around it. If this is the direction of your current, that means using right hand thumb rule, this is right hand thumb rule, this is the direction of current, this will be the direction of magnetic field. That means direction of magnetic field here will be above the plane, and here direction will be below the plane. That means you have to show with cross and one your circle. This is below the plane. And we are going to find magnetic field due to current carrying a small element. Small element, this is the small element, and this element is dl vector. dl vector. And current element is I dl vector. This is I. And its direction is this one. And here this is vector r. This is vector r. And this is point P, and we have to find magnetic field due to this current element I dl at point P. So direction to pata chal gaya. Direction is below the plane. Now we are going to find the magnitude. What will be the magnitude of your magnetic field at point P? The current carrying wire produces a magnetic field around it. Biot-Savart's law states that magnitude of intensity of a small magnetic field. A small magnetic field is denoted by your dB. dB is small magnetic field here due to current carrying element IDL at point P at a distance r from it is given by, here dB magnitude is equal to mu naught by 4 pi, mu naught by 4 pi into I dl sin theta, I dl sin theta divided by r square. Here I dl is current element, and here r is distance, and theta is angle between I dl and vector r. This is here, and this theta is angle between your r and dl. Mu naught is equals to, here mu naught is 4 pi into 10 to the power minus 7 Tesla. This is T m per pair. This value is called permittivity of free space. You can write here, this is permittivity of free space. Here magnetic field due to current carrying straight conductor or wire. This is a wire. In this case here, length of wire is finite. That means finite length of wire. That means wire has finite length. Magnetic field due to finite length of wire at point P is given by BP. That means magnetic field at P is equal to mu naught times I divided by 4 pi d. D is distance, and here sin theta 1 plus sin theta 2. Derivation of this result will be in next session. तो next वॉल्यूम में हम लोग इसका डेरिवेशन देखेंगे, बट हियर हम लोग देखते हैं इसका फॉर्मूला क्या है. हियर दिस इज द वायर ऑफ फाइनाइट लेंथ. फाइनाइट लेंथ मीन्स हियर दिस इज L to N, एंड मैग्नेटिक फील्ड एट P ड्यू टू दिस करंट कैरिंग वायर. तो इसका डायरेक्शन देखिए कैसे होगा. मैग्नेटिक फील्ड डायरेक्शन जो है अपवर्ड है, करंट का डायरेक्शन. तो मैग्नेटिक फील्ड विल बी हियर बिलो द प्लेन. दैट मीन्स दिस इज क्रॉस, and this side will be above the plane, and length of wire is finite. This angle is theta 1, this is theta 2. तो इसके एक्सट्रीमिटीज से देखते हैं कि एंगल कितना बन रहा है. तो theta 1, theta 2 and mu naught times I is the amount of current and 4 pi d. D is distance. This is infinite length wire, minus infinity to plus infinity, and P is any point. Again here direction will be here. Current direction is upward, and using right hand thumb rule, direction of magnetic field will be here below the plane, and this is here in this side above the plane. And what will be the value of magnetic field at this point? Here theta 1 is 90 and theta 2 is 90. That means BP will be put mu naught I, and here 4 pi d. D is distance, I is value of current, and sine 90 plus sine 90. Sine 90 is 1, that means 112. That means here this is mu naught, this is mu naught I divided by 4 pi d into 2. Cancel, that means value will be mu naught I divided by 2 pi d is BP, magnetic field at P, due to wire having infinite length.